Okay, so in this particular problem, we're supposed to find the energy stored in the inductor at t equals 0 minus. So that means we have to find IL of 0 minus. We knew we were going to have to do that anyway. Anytime you have a problem with an inductor and a capacitor and you've got some sort of switch action, an inductor or a capacitor, you'll want to find the current through the inductor at 0 minus and the voltage across the capacitor at 0 minus, because those are the things that are most important and can't change. You're always going to want to find those. And then I already have written up here, I was looking ahead that we needed to find dV dt across the capacitor, and I was just pointing out that I equals dV dt. So if we just needed to find dV dt at a particular time, at time t equals 0, we can find the current at 0, and that will help us find the voltage. So when we get to that part, we'll have that. So with all of these problems, we have to see what the circuit looks like at 0 minus. At 0 minus, capacitors are open circuits, inductors are short circuits. So we're going to redraw this with our capacitor as an open circuit and our inductor as a short circuit. And y'all need to keep an eye on me on this problem, because I kept messing up when I was doing it myself. I kept messing up my signs and making positive and negative mistakes, so hopefully I don't do that this time. Okay, so this is where our inductor is, but at 0 minus it's acting as a short circuit, and this is where our capacitor is, but at 0 minus it is acting as an open circuit. So if I made this right here ground, then I would say this side of the capacitor is at 0. This side of this voltage source, this is plus minus, the bottom side has to be 6 volts higher. The plus side has to be 6 volts higher than the minus side, so I have to have minus 6 volts up here. Now, there is no current flowing through this branch right here because it's open. But just because there's no current doesn't mean there's no voltage. There is a voltage source sitting right here. And this voltage source tells me that the positive side of the voltage source has to be 12 volts higher than the negative side of the voltage source. There's no current flowing through this resistor, and so the voltage doesn't change across the resistor. It's minus 6 volts right here. It's minus 6 volts all the way across there. But with this voltage source, it has to be 12 volts smaller on this other side, so it has to be minus 18 volts right here. And so if you look at our capacitor, it's labeled with a plus here and a minus here. So VC of 0 minus is minus 18 volts. It's minus 18 because the positive side is at negative 18, the negative side is at 0. So that wasn't what we needed to find yet, but I promise we're going to need it somewhere. Okay, we do need to find the current through the inductor, and we can do that. By looking at our voltage here, we have, okay, so you have a question? Okay, so if I'm looking at the current through the inductor, I want the current going through the side that's labeled plus and to the side that's labeled minus. So I have 0 volts right here. And going around to the other side of this resistor, I have minus 6 volts right there. And so the current going in this direction, so the current through the inductor will be 0 minus negative 6 over 1.5, which is 6 over 1.5, which is 4. amps. So that is the answer to part A. No, it's not. That just got us the current. We need to find the energy. The energy in an inductor is 1/2 L I squared. So that'll be 1/2 times L is 1 Henry. I love inductors because they always have like nice values like 1 times our current, which is 4, another nice value, squared. So 4 squared, that's 16. These are all just no millis, no kilos. 16 times 1/2 is 8, so U equals 8 joules. So that is our answer to part A. And let's see. No chat, okay. Now for part B, any questions before I go on to part B? Okay, so part B said to find dVc dt at time t equals 0. Well, I know that the current through a capacitor equals C dVc dt at time t, at whatever time, and I'm looking for a time t equals 0. So I at t equals 0 over the capacitance will equal dVc dt. So let's see if I can see the current through the capacitor at time t equals 0. Now it's 0 plus. So I now need to redraw my circuit at 0 plus. So let me grab that. Did I not start recording this? No, I'm recording it. Okay, good. Okay, so at 0 plus, the switch has opened. So, and our capacitors and inductor is going to start acting, start functioning. So this is open now. So this branch right here is truly not doing anything. So it does have, it is true that the top of it is 6 volts lower than the bottom of it, but there's nothing at the top of it for us to worry about. So we're not really concerned about that one. We do know that the current through this inductor going in this direction was 4 amps. We also can see that everything in our circuit is in series, and so we have that make sure I have this right. Yeah, I do. Okay, that the current through our capacitor also has to be 4 amps. Now our capacitor is labeled plus on this side and minus on this side, so I want the sign of the current as it's coming in on this side, and our current coming in on this side is 4 amps, and so IC of 0 plus is 4 amps. Now IC of 0 minus was 0 amps. That's okay. The current across a capacitor can change instantaneously. The voltage cannot, but the current can. And so the current has to be the current through the inductor. because the current through the inductor cannot change instantaneously. And so we now have, we had that IC of 0 over C equal dV dt. And so I have 4 over my capacitance is 0.1 equals dV dt. So 4 divided by 0.1 is 40. Now dV dt, that is change in voltage over time. All of our units are normal units, so change in voltage over time is volts per second. So dV dt at t equals 0 is 40 volts per second. Okay, now the last thing I need is to find VC at infinity and VL at infinity. So let me draw my circuit. Okay, so did I actually not end up using that minus 18? I feel like I did. Oh, I never found VL of 0 plus. Okay, I found VC of 0 plus, and I found IL. Okay, okay, that's what. Okay, I never finished. I didn't finish part A. So I found. I did find VC of 0 minus was 18 volts. We know that VC of 0 minus has to equal VC of 0 plus, so that also has to be 18 volts. I did not find VL of 0 plus, so I need to go back and do that. So this is going back to part A. I do have this circuit here, so I know that I had this plus this minus. This was minus 18 volts. We found that. This is a voltage source that is 12 volts. We know that the current, am I missing a resistor? I think I am, yeah. We have a 6 ohm resistor, and I have a 1.5 ohm resistor. I know that at 0 plus, I have a 4 amp current going this way. If I say that if I make this ground, so that's ground, that'll be 0. I know that this side over here needs to be negative 18, because it has to be 18 volts lower than it was here. This is 12 volts. The plus side needs to be 12 volts higher than the minus side. The minus side is at negative 18, so this would be at negative 6. And so going from point A right here to point B right there, I can say that my current, if I call this VA and this VB, my current will be VA minus VB over the resistance, and that's going to be 0 minus -6 over my resistance. I have two resistors in series, so that'll be 7.5. So that'll be 6, and that has to equal, oh, sorry, no, I take that back. It's not 0. I, that is true, but that doesn't help me because I'm trying to find the voltage across the inductor. So I really want the voltage right here, which is my unknown. So I will call that VL. So VL minus -6 over 7.5 equals 4. Or VL plus 6 equals 4 times 7.5, and 4 times 7.5 is 30. Or VL equals 24. Okay, except that's not, VL was not really the best name for it, but I'm saying it's 24 right here. So the voltage is 24 right there. It's 0 here. If we go back and look at how this is labeled, this is plus, this is minus, this is the plus side, this is the minus side. So when I list what VL is, I list the positive side minus the negative side. So VL of 0 plus is 0 minus 24 is negative 24 volts. Okay. Now I think I'm ready to go to infinity. Okay, so at infinity, once again, our capacitor will be open and our inductor will be short. So we're supposed to find VC at infinity and VL at infinity. Across any short, the voltage is 0. So anytime you have the short, the voltage is 0. So that one is easy. It's a short, so the voltage has to be 0. What about this capacitor? Well, we don't have any current flowing at infinity because our capacitor is open, our inductor is short, but the open capacitor is going to keep current from flowing. But this side of the capacitor, which is labeled as the plus side, is connected to the negative terminal of our voltage source, and this side of the capacitor is connected to the positive side of our terminals of our voltage source, and our voltage source was 12 volts. So that tells us that since it's connected and there's no current flowing, this side, if I call this ground, this side is at 0 and this side is at 12. So our positive side, so if I want VC at infinity, I would take the voltage at the positive side, which is 0, minus the voltage at the negative side, which is 12, and that gives us minus 12 volts. So that is VC at infinity. Okay, any questions from anyone?